Hi everyone, my name is Ian. I'm here with my colleague Carlos, and we're going to talk to you about vehicle and city simulation with Gazebo and ROS. So a little bit of background. There's certainly been a lot of interest in vehicle simulation, as we've seen in the morning and in the afternoon throughout all this day. So we thought we'd like to share with you some of the projects that we've been working on. So we are in the simulation team in Open Robotics. So we share some of the projects we've been developing in simulation and how we take those results and convert them into resources that we made publicly available for everyone to use. So they include vehicle environment models, plugins for controlling cars, road network parsers, and also procedure CDs generation tools. Okay, so one of the first projects I'd like to talk to you about is a simulator that we made for the Prius Challenge event. This is an event hosted by Toyota Research Institute. So I believe they've been running this event inside Toyota annually for a while, and this year is the first time they made it public for everyone to participate. So a little bit about the event. So you drive a Prius hybrid inside a raceway, and then what you're doing here is you're competing for the best fuel economy instead of competing for the best time. So they have to drive rear Prius vehicle 9 laps under 45 minutes and really looking for really high MPG. The goal is to get 100 plus MPG, and then I think before the race day they hired professional drivers on the racetrack and was able to make that number. So you just see on the right, just a photo of the Prius hybrid, and then the back is the photo of the raceway. And we're just going straight to a demo. So the simulator that we built for them is for the teams to practice. So I have my colleague Carlos there driving the simulator with the joystick. So they get to use the software to practice before the actual race day, because now everyone can spend thousands of dollars renting the raceway. So what you see here is just a browser. So we run the simulation on the cloud. All they need to do is just log in through a browser, go to URL, and then plug in the joystick, or if they have keyboard or a driving wheel, they can also just plug it in. It should just work out of the box. So so this is a camera view from the driver's seat. And then what you see in the background is just a 3D model of the Sonoma Raceway. So we hired 3D artists to create these for us. And also what you cannot see here is the vehicle, Prius hybrid. We also have a 3D model for that, and we're making all that publicly available. We also implemented a powertrain system. So all the data down here, and which the most important part, the miles per gallon, the state of charge, and also you get data like the speed, distance traveled, whether or not EV mode is on, and which gear the car is in. Hopefully that gives you an idea of what we created. So this is the Prius hybrid model. So a little bit about how we model in Gazebo. So it's Ackerman steering, and we have rolling resistant model as joint friction. So this is just adding friction to the joint connecting the wheels to the chassis. We have simplified approximated aerodynamic drag, just adding forces to the body of the link. And also added suspension model. Because of the nature of the raceway, there are a lot of steep climbs and bank turns, so we allowed the axles to wheel a bit, to roll a bit, so that the wheel remains contact with the ground. As for the wheels themselves, we increased the friction coefficients on the rear wheel so that it's understeer and prevents the vehicle from spinning out. And we also use, for example, sphere as collisions, so that it only generates one single contact instead of cylinders, which you can make it popping contacts and produce unstable behavior. Perhaps the feature that we spent the most time on is the Powertrain Model. So we created a plugin for this. so my colleague Steve Peters spent a day at Sonoma Raceway collecting data from the real Prius hybrid model. And from there, he was able to fit a model and derive parameters such as the efficiency of the battery, the gas engine, and the charge and recharge rate. And also, we implemented the plugin to capture the different states of the powertrain system. So, for example, when the engine is on, when it's actually drawing power from the battery, and so on. So for more detailed analysis, you can find a link down below. We have a QR code at the end of the presentation, so that point gives you a link to this presentation. So you can get the links there too. So we spent a little bit of time after this project to tidy everything up and create a open source project, a demo for this, so that we're hoping that this would be a good starting point for anyone wanting to get into vehicle simulation for their cars projects. So put it on GitHub, it's down below. Just going to play the video. So we use ROS Kinetic, and we converted the Prius SDF model into URDF, so it's ROS friendly, so you can visualize in RViz. Also, we added different sensors to it, planar LiDAR, block LiDAR in the middle. We have an array of sonar sensors, and then we have added cameras on all sides of the car. And maybe you can see in the video there, the background, the environment there is not Sonoma Raceway, so we actually created another model that's the M-City test facility. It's a real physical test bed from the University of Michigan. The nice thing about that model there is that it has intersections, lanes, lane markings, buildings, and curbs that is good for testing self-driving cars. And finally, the last example I want to show is a project done by one of our interns, Rohit Salam. So he applied deep learning to drive the car autonomously around the racetrack. So this is a simple demonstration built on top of the car demo that I presented in the previous slide. Applied deep learning based on the NVIDIA end-to-end learning model. From there, you may have noticed there are also object detection. So what he did was he drove the car manually around the racetrack a few times, collected ROSPec files, and from those ROSPec files, he was able to get images, steering angles, and basically just using all that information to build a model. And from there, he was able to drive the car by herself in simulation. So for the object detector, he created YOLA object detector and TensorFlow object detector, and those are all open source. And I'll now pass on to my colleague Carlos to talk about other tools.
Thanks. Ian has covered so far different types of resources, such as vehicle models, environment models, and also plugins. And the next type of resource I'd like to present here is a C++ library named Ignition RNDF. And RNDF stands for Route Network Definition File. And this is essentially a specific format of capturing all the road properties. And there are like different, of course, this is not the only format, there are different ones. And essentially the general term, it's the road network definition. And this is important because if you think from the perspective of the code that's driving our cars, we need a way, or the code needs a way to access programmatically all these properties. I think we saw interesting videos and talks this morning about this. So Ignition RNDF is, the main goal is to deal with these type of files, essentially with the RNDF files. So the main goal is to load an RNDF file from disk into memory and offer or expose a C++ API to read, write, and delete the different elements of an RNDF. And you can see here on the picture, just to give you a quick overview of some of the elements of an RNDF file. So you can see two different segments. So the horizontal one and the vertical one are those two segments. Each segment has lanes. So in this example, there are 2 lanes per segment. And then each lane has different waypoints, which are marked with latitude and longitude. So we can see different circles here, the blue, the green, and there's also stop signs captured in RNDF, so you can see one here on the right side. So Ignition RNDF lets you load all these files and parse, as I mentioned. It's also a C++11 library. It's cross-platform. So it works on Windows, OS X, and Windows. And it's one of the very limited open source options available. So you can also access the library here in the link. And the next resource I'd like to present here is called Terminus. But first things first, I like to introduce Ecumen because those were the original authors of the tool. So the goal of Terminus is to generate a city that can be loaded into simulation. This is pretty important because we have identified multiple use cases where this could be interesting. Imagine you don't have access to a real vehicle, so you only have a simulation. It's pretty cool if you can reproduce the city that you need. Maybe first of all, you want to try a city like this one with a lot of symmetry. Maybe you want to keep moving to different shapes. So with Terminus, you can kind of create the city that you need. But there's also different use cases. For example, imagine that you already have a vehicle and you start testing on the real world, and you identify some particular situation that happened. So it would be nice if you can go back to the lab and try to identify what happened and maybe import the same area of the real world that you used, and again, test your code to see what happened. We'll see that most of these use cases can be reproduced in Terminus. And then the last use case I'd like to mention also is maybe you have a car, maybe you have everything, but you still want to, again, generate a city with the features, an artificial city with some particular features. So Terminus lets you specify with different parameters, dimensions, density, and shape to create the city that doesn't exist maybe in the real world. So for now, the content that Terminus generates, the content of the city that you can generate, is composed by buildings and roads. So for now, those are the two main elements. And also the city can be exported or generated into different formats. You can generate an Rdf file, so if you're only interested in the roads, or you can generate the entire city, for example, in a world file that can be loaded into Gazebo, or you can generate a mesh that can be loaded into a different simulator. For example, we tested this with the Drake simulator. And I'd like to show a small video also of the tool. So just a little bit of context before playing the video. So imagine that, so what's going to show here, it's an example of how to create a city of an area of the world that exists. So the way we created this is we use OpenStreetMap. So what you would do is you open your browser, go to OpenStreetMap, and then select a region of the world that you're interested in. In this case, we select a region of Madrid. This is on the upper left. This is a snapshot of the region that we loaded. Beautiful city, by the way. And then what we did was click on the export button on OpenStreetMap, and that will generate a file for you. This is still not Terminus. And the content of that file is XML of that area with all the information about buildings, roads, and all that stuff. Then you can imagine Terminus is like a script, and then we pass all that file or all that data contained in the file into the script. And then we run Terminus and generated the different files that are here in the lower left side. So the first file we can see is a 2D, or just a plain 2D file of the road generated. Then there's also an RNDF. I'm going to pause for a second. Terminus also generates an RNDF representation of the roads, and this is an SVG also visualization of that RNDF. So there are different tools here to help you visualize what has been generated. You can also, what we're seeing here is the mesh of the road also generated in OBJ format. And then finally, this is one of the .world files loaded into Gazebo. As you can see here, the buildings and the roads. So to summarize, we have presented different type of resources that we believe could be interesting and yet another step into the direction of autonomous vehicles. And we have presented different vehicle models, such as the Prius, different environment models, such as the M-City and Sonoma Raceway, examples of plugins that can modify the way Gazebo works for our own needs, examples of C++ library that lets you deal with road networks, and also a new tool called Terminus for generating cities and loading in simulation. But of course, we know that that's not enough. So as I said, that's just one step. And we encourage everyone to contribute and improve all these tools. For example, it would be great if we can have more models, more bikes or trucks or sidecars or RVs or trailers, more environments, more curated environments, different plugins, for example, for controlling traffic lights, or weather conditions, or move different groups of pedestrians. Also, Gazebo has different, or a wide variety of sensors, but for example, the radar is not fully supported yet, and seems a pretty important sensor for autonomous vehicles. So we're looking also for contributions on that topic. And we introduced here Ignition RNDF, but RNDF is not the only format. Of course, it has its own limitations. For example, it doesn't have elevation, or it doesn't contain information about the geometry of the road. So we're looking forward for more formats, such as OpenDrive or any other formats. And we're also thinking on creating a common API for accessing all the elements that, in a way that your code doesn't change, sorry, independently of the format that you're using underneath. And of course, improving Terminus or other tools, for example, for adding more content besides roads and buildings. And of course, create more cities and store them in a common repository that everybody can access. Thank you, and we're happy to take questions.
Great, thank you. Anyone have questions? And while the people are asking questions, Louise, you want to get set up? So while she's getting set up, which parts of these are easily reproducible right now?
Which parts are reproducible?
Like a quick demo so people can run.
So pretty much everything that we show is available, except for the ROS demo, you mean? Oh, the self-driving car simulation. Yeah, the video that we saw where the car is just going autonomously. Yeah, the rest of the resources are available. There are links and everywhere.
I have two questions. Maybe I missed the first one in the presentation. So, like, I can create a 3D map of any city using Openstreetmap. So, like, I take an image and put it through Terminus, and I will be able to get a 3D map of that city. Is that correct?
That's partially correct. So you're not going to get a full 3D map of the city. You're going to get all the roads of that area.
Okay.
And the buildings.
And how precise is the map with the reality? Do we have any metrics on that?
That depends on the precision that OpenStreetMap has.
Okay.
So we're not generating that data. We're just importing data from the web.
All right, thanks.
Sure.
So you simulate your car with the Prius challenge in your simulators, and how well does that transfer to the real world?
So I think we don't, the people use the simulators just to not get an idea of how it feels to drive it on the actual racetrack, get an idea of the elevation gains. In terms of accuracy, we don't have exact data to quantify that. but I think people have been using it quite a bit to devise the strategy for driving, but we don't have any accuracy data.